All right, well, thanks for coming. So somebody yell at me if you can't hear me. Just give me 1 second. So I'm Michael Rabenberg, and I'm a postdoc at the University at Buffalo. And I'm going to discuss a project that I've been working on with Werner Kirsters and Anawat Pengput, who are also of the University of Buffalo. And I think I see that Anawat is in the Zoom audience right now. So we've been developing a kinship ontology with a few key features. I'm sorry, something funny is happening with the sound. Give me a second.
Now it's good.
Maybe so.
You can.
Am I good? Maybe somebody was unmuted or something. I don't know.
You can start. There is a person with the mic on.
Okay. All right. So our ontology builds off of an extant kinship ontology. It has applications to biomedical informatics. It's conformant to BFO 2020 first order logic, or FOL. It's linked to SNOMED CT in an important way, and it's extendable. And I'll say something about each of these features in due course. Kinship ontologies are ontologies concerned with familial relations. They can be concerned exclusively with biological familial relations, such as natural parent of and natural sibling of, or they can be concerned with familial relations more generally, including both biological ones, like the ones I just mentioned, and other relations, such as has spouse or parent of. They can be realism-based or concept-based, and they can be rendered in more or less expressive logical languages. Kinship ontologies can serve some valuable biomedical informatics purposes, and our own project was motivated in part by a public health issue to which accurate representation of kinship relations is relevant. Cholangiocarcinoma, or CCA, is a lethal bile duct cancer that's a significant public health problem in Thailand. In 2013, the Khon Kaen University developed a study called the Cholangiocarcinoma Screening and Care Program, or CASCAP. People involved in CASCAP are asked several questions, and one of them is, do you have any relatives diagnosed with CCA, cholangiocarcinoma? When this question is answered in the affirmative, the options on the screen are presented as categories, right? So a couple of explanatory points about these terms. First, the Thai terms, of which these are English translations, all refer, aside from the term for spouse, to biological relative categories. So for example, paternal grandparent in this context means specifically biological parent of one's biological father. Furthermore, older uncle or aunt and younger uncle or aunt are translations of Thai terms referring to an older or younger biological brother or sister of one's biological parents. And I'm grateful to my co-author, Anawat Pengput, who's a native Thai speaker, for explaining these matters to me. Now, one of our goals in developing our ontology was to include definitions of the kinship relations corresponding to all of these terms. For example, natural daughter of. And we wanted to do this for a few reasons, among them to facilitate ontology-based reasoning on a collection of CCA data linked to medical records, with the goals of detecting data entry mistakes, resolving ambiguities, tracking changes in entities over time, and drawing attention to survey questions that are prone to different interpretations and so ought to be rephrased in future versions of the survey. For example, if a respondent says at one time that he has a son with CCA, natural son with CCA, and at a later time says that he doesn't have a son with CCA, well, it might be, for example, that the son died in the intervening period, but it might instead be that the CCA was successfully treated in the intervening period. Another goal of ours was to reuse, to the extent possible, kinship axioms and definitions that already exist. So there are a lot of extant kinship ontologies, and in the paper, we give overviews of several of them. But in the interest of time, I'll just say a little bit about the particular kinship ontology that we used as the primary starting point for our own project. It's called Kinship, and it's presented in a recent paper by Chui et al. The ontology is axiomatized in first order logic, and it contains the 13 axioms that you see on the screen. 1 through 8 are concerned with the natural ancestor of relation. 9 through 12 are concerned with has spouse, and 13 is concerned with both of these relations. You'll notice that Chui et al. Themselves use the phrase ancestor rather than the more specific term natural ancestor. And in general, they don't append terms like natural to terms that admit of non-natural readings like grandparent. But it's clear from the discussion, their discussion, that when they use those sorts of terms, they mean them to carry blood relative senses. Some other strictures on our ontology were that it be realism-based and fully conformant to the BFO 2020 FOL axiomatization, and that it be linked with SNOMED CT in a way that I will elaborate on in due course. Okay, so now let me describe how we went about developing our ontology. We first manually inspected the axioms in Kinship to assess the extent to which they are or aren't faithful to the aspects of reality to which they pertain, and so fit or unfit for inclusion in a realism-based ontology like our own. So for example, consider the axiom on the screen from Kinship, which I here call A1, which just says that the ancestor of relation, is irreflexive. If we thought that there were counterexamples to A1 involving backwards time travel or something like that, then we wouldn't have incorporated it into our ontology, at least not in any straightforward way. Now, one important part of this step of the project was identifying axioms in Kinship that are almost true. For example, consider this one on the screen, A2, which says that X has child Y just in case X is ancestor of Y and X is an ancestor of someone who is ancestor of Y. Okay, A2 is false. Appearances perhaps to the contrary, but the situations that counterexample A2 are very unusual. People do not ordinarily have natural children who are natural descendants of their own natural descendants. So if you're familiar with the classic film Chinatown, you know that one of the big revelations toward the end of the movie is that one of the characters had fathered a child with his own daughter. That would be a situation of the sort at issue. Okay, so A2 is false, but it's almost true, right? And almost true axioms were not straightforwardly included in our ontology. They're false, but they aren't excluded entirely from it either. Instead, we've adapted them into what we call unusual case axioms, and I'll say more about them later. Okay, so we next rewrote the axioms accepted thus far so as to be compatible with the BFO 2020 FOL axiomatization. One part of this step of the process was rewriting predicates, which from BFO's perspective qualify as phantological in Barry Smith's phrase. So for example, here's an axiom from Kinship, which I here call A3 on the screen. Now, in first order logic, as used in Kinship, ancestor of and person are relations, binary and unary respectively, that hold for certain individuals in the domain of discourse. And first order logic allows one to predicate something about individuals in the domain without being bothered by any attendant ontological commitments. Now, BFO might commit to ancestor of representing an instance level formal relation, but BFO would not commit to person, the term person representing a formal relation. Instead, it would take person to be a universal that is instantiated by a particular at a time. So a BFO compatible first order logic translation of A3 would look like the thing I've called A4 at the bottom of the screen. And in general, any axiom that describes an individual as timelessly standing in some unary relation, as in first order logic, phantologically conceived, to again use Barry Smith's phrase, or as timelessly being a member of a class, as in OWL, any such axiom required revision for BFO 2020 FOL compatibility at this stage in the process. We then replace terms for certain relations and universals with terms that better express what's intended, at least on our end. For example, we replaced occurrences of ancestor of with occurrences of natural ancestor of to make explicit that our axioms containing this expression are concerned with natural ancestry and not with just ancestry more broadly. And we replaced occurrences of person with occurrences of human being, for example. So, for example, here you can see at the bottom of the screen what happened to A4, for example, at this stage in the process. After that, we formulated definitions of the relations referenced on the CASCAP form and axioms detailing relations between those relations and the ones accepted thus far. So one axiom included at this point for the natural sibling of relation is at the bottom of the screen. Only one relation that is referenced on the form, namely the has-spouse relation, was not addressed at this stage because it had already appeared in our collection of axioms because it was in T-Kinship. Now, after that, we devised SNOMED CT bridging axioms, which link from the relations and universals referenced in the axioms produced so far to corresponding kinship terms found in SNOMED CT and vice versa. So SNOMED CT is a very large concept-based biomedical terminology. One SNOMED CT concept is the blood relative concept, under which fall a number of concepts that correspond to relations that are treated in our ontology. So, for example, natural child, which is on the screen, is one SNOMED CT concept that falls under the SNOMED CT blood relative concept. And so here are two axioms that we added at this point, the ones on the screen. So A5 says that if X is an individual of the SNOMED CT natural child concept, then someone has X for a natural child, and A6 says the converse. Now, one can write many of these axiom pairs, including this pair, as biconditionals, but we didn't do so in order to achieve a more fine-grained modularization of our axioms, which I'll say a little about later. We then devised a set of unusual case axioms, which characterize certain unusual ancestry and spousal situations as unusual. These are the axioms that were inspired by the almost true axioms from T-Kinship that I discussed a little bit ago. For example, from A2, the Chinatown T-Kinship axiom, you might call it, that I talked about a little bit ago, we derived A7, which basically says that if three people occupy a Chinatown situation, then they occupy an unusual ancestry situation. Okay. So why did we do this? Well, unusual case axioms can serve some valuable data checking purposes. For example, suppose somebody enters into an EMR data that trigger one of the unusual case axioms by, for example, entering data to the effect that John is natural parent of Anne is natural parent of Mike, and John is natural parent of Mike, as at the bottom of this table here. Well, then a warning message can be devised recommending that the entered data be double-checked for accuracy. And given how unusual the situations in question are, the triggering data entry will often have been erroneous. So that was the reason for the unusual case axioms. Okay, so after that, we translated our axioms into CLIF following the schema of the BFO 2020 FOL axiomatization in CLIF. We used a parser generator of Werner Kursus's design to transform the axiom collection in a Kowalski rule base, and we used that as an input for a reasoner, also of Kursus's design, for satisfiability testing. And the result of our work is a kinship ontology that we've divided into 6 modules. The main module contains most of the kinship axioms and definitions proper, including the BFO conformant variants of T-kinship axioms that we preserved, and the definition axioms corresponding to most of the terms on the CASCAP form. It also contains bridge axioms linking universals to BFO categories. For example, an axiom to the effect that everything that is an instance of human being at a time is an instance of object at that time. Okay. Sorry, I was just reading the chat. The other modules contain definitions of the older and younger uncle and aunt of relations, the SNOMED CT bridge axioms, class declarations for the SNOMED CT concepts referenced in those axioms, and the unusual case axioms. Okay, so that's what we've produced, very quickly summarized. Now let me say some things about two of the relations that are central to the ontology, has natural child and has spouse. The has natural child relation is at the heart of the ancestry axioms in the ontology. For example, the natural ancestor of relation is defined recursively partly in terms of it, and not the other way around, as in the rejected A2 Chinatown axiom. And other blood relations are defined in our ontology partly in terms of one or the other of these two relations. So by, for example, has natural child Amy Bob, we mean that among the gametes from which Bob originates is a gamete of Amy's. And by of Amy's in this context, we don't mean, for example, owned by Amy or controlled by Amy. Rather, we mean having its biological origin in Amy. So if Claire has sold one of her ova to Amy, okay, then this ovum is, in a loose sense, a gamete of Amy's, but it's not a gamete of Amy's in the sense relevant here. Now, all of that stuff could be axiomatized as well, but in light of CASCAP, doing so would not at present bring any advantages. We use the term spouse to pick out a marriage partner, and by, for example, has spouse Yvette Zorro, we mean that Yvette has a marriage partnership with Zorro. We assume, and we have axioms to the effect that if X has spouse Y, then among other things, there is a marriage bond that inheres in X and Y and that exists at a time at which X and Y exist. This assumption secures the intuitively correct verdict that spousehood is a temporal matter. People are not simply atemporally spouses of one another. And in this way, spousehood seems to contrast importantly with natural ancestry. For natural ancestry relations do seem to be atemporal. At any rate, our ontology reflects this view by, for example, not time indexing the natural ancestor of relation. Okay, so I mentioned at the outset of this presentation that our ontology is extendable. I will close by discussing some ways in which it could be extended or revised, and so point to some future directions in which this work could go. I mentioned already that our ontology contains SNOMED CT bridging axioms. It also contains bridges to the non-concept-based top-level ontology BFO in the form of axioms to the effect that, for example, everything that is an instance of marriage bond at a time is an instance of relational quality, which is a BFO category at that time. And so our ontology serves as a link between SNOMED CT and BFO, and it shows that they can, at least to some extent, be used together in a logical framework without the ontological commitments of the one getting imposed on the other. We hope to apply this general bridging strategy to other SNOMED CT concepts in the future. For example, there are many additional SNOMED CT blood relative concepts that we haven't touched at all. For example, there's a SNOMED CT concept for identical twin brother, but we obviously haven't linked this concept to our ontology in any way. Still, the work we've done thus far could be extended so as to cover other SNOMED CT blood relative concepts, and we hope in future work to do that. Also, our ontology doesn't at present cover non-blood familial relations beyond spousehood, such as domestic partnerships and friendships. It could be extended to cover more such relations and their SNOMED CT concept analogs. And finally, it's possible, and it may well be advisable, to revise our unusual case axioms so as to suit particular data entry and inspection contexts. So for example, here's one of the unusual case axioms. The intuitive idea here is that if two people are co-natural parents of a common person and they are themselves close blood relatives, then they and their child occupy an unusual ancestry situation. The long highlighted disjunctive clause specifies a range of blood relations that qualify as close. But of course, there are other close relations not covered by the clause, for example, natural second cousin of. Adding additional such relations to the disjunctive clause would allow for the generation of additional data entry warnings. But expanding the clause in certain imaginable ways would also generate enough warnings, or could also generate enough warnings in cases of correct data entry, that doing so would be, all things considered, unhelpful. So for example, if one were to revise A8 in such a way that co-natural parenting natural seventh cousins count as occupying an unnatural ancestry situation, then perhaps you would thereby revise A8 in such a way that it yielded a counterproductively large number of false positives. This just seems like the sort of thing that can't be resolved without some trial and refinement and some relevant data about the population that you're focused on. Similarly, A9, which marks as unusual plural spousal situations, is one of our unusual case axioms. But if, for example, one lives in a society in which, I don't know, polygamy is very common, for example, then it might be a good idea for one not to adopt A9 at all. The point is that these axioms should be regarded as appropriately subject to refinement or even outright rejection, depending on circumstances. Okay, so let me summarize. We've developed a novel kinship ontology in first order logic following the representational principles of BFO 2020 FOL. It comes in separate CLIF modules, each of which can be imported based on specific needs. For example, mapping to and from SNOMED CT, or generating alerts on possible data entry mistakes. The ontology can be used directly by CLIF reasoners, or the axioms can be translated into variants suitable for OWL description logic reasoners, but at the price of loss of information and reasoning capability. In future work, we intend to expand on this project by adding SNOMED CT kinship concepts that we haven't yet wedded to our ontology through definitions of corresponding relations or production of relevant bridge axioms. And further expansion following the same bridging strategy might happen when other relevant kinship terminologies become prominently used. Okay, thank you very much.